All right, so today we're going to be working with some two-step equations. Okay, the process is not that much different than working with a one-step equation, okay? It's just we're repeating the process multiple times, okay? Our goal is still the same. We want to isolate the variable, and how we do that is by using inverse operations, okay? So our goal is still going to be to isolate the variable, and how we do it is still going to be by using inverse operations. You guys remember what inverse means? What word should we be thinking about when we think inverse? What word comes to mind? Opposite, right? Okay. So let's run through some examples together. Okay. Okay, so go ahead and write this one down. Okay, so we've got 2x plus 7 equals negative 13. Okay, so what I'm going to do is I'm still going to look at where my equal sign is. I'm still going to draw my imaginary line to help me see the left side from the right side. I'm going to still start on this side with a variable. So since the variable's over here, this is where I'm going to start. Okay. Now, I see that around this side, I have multiplication and I have addition. Okay. And so what I want to do is I want to undo one of these operations. Now, what I'm going to tell you guys is leave the one closest to x for the end. Okay? So see how the 2 is multiplying by x? It's like actually touching the x, right, which implies multiplication. I want to leave that until the end. Okay? So if I have multiplication or division by the x, I'm going to leave it till the end. So I'm going to start with removing the number that's adding or subtracting. Okay? So what's the opposite? I have adding here. So what's the inverse operation of addition? Subtraction. So I'm going to go ahead and subtract. Okay? And so here's what I get. These make 0, right? What's 2x plus 0? Just 2x. Okay? And now, what's negative 13 and negative 7 over here? Negative 20. Good. Okay. So, what property did I just do here? What property was this that I applied? Subtraction. Property of equality. Is it okay if I abbreviate property of equality? Okay. Now, tonight on your homework, you're still going to be justifying your steps, okay? You're still going to be checking your solution, all right? Okay, so now I get to this part, and now I just have a one-step equation. This is what you guys have been practicing, right? So how do you undo multiplication by 2? What is the inverse of multiply? Division. So let's go ahead and divide on both sides. 2 divided by 2 is 1, and 1 times x is just x, right? What's negative 20 divided by 2? Negative 10, okay? Now, what property did I do right here? Division, right? So my next step, justification, is division property of equality. Okay? Now, I'm going to make sure that I check my work, okay? So I'm going to set up a check over here. And when I'm checking my work, what number am I plugging back in into the place of x? Negative 10. So I'm going to get 2 times negative 10 plus 7 should equal negative 13. Now I'm going to work this side out and see. So what is 2 times negative 10? Negative 20. What is negative 20 plus 7? Negative 13. Did it end up checking out? Yes. The left side equals the right side. Okay? So, are there any questions on what we did here? We're just doing multiple steps now, right? Instead of just one step, there's going to be multiple steps in solving. Okay? Does everyone have this written down on their page, including the check, before we move on? Everyone's good? Okay. All right. So, let's take a look at another example. Let's take a look at this one. Let's see if you guys can try this one. Okay, I'm going to give you guys a moment to write it down, and then I want you to turn to your new shoulder partner and see if you guys can work through this one together. Compare your steps, compare your justification, compare your answers, and make sure you check your solution. Okay? Take a minute to work on that. Okay, so let's take a look at the solution. Okay. So first of all, did everyone end up with x equals 8? Yes? Okay. So help me justify my steps. What was this first step I did? Subtraction, property of equality, right? Okay. What was the next step I did? Division, property of equality. Okay. Now, what did I still not do yet that I was supposed to do? Did I check my work? No. Okay, so let me check my work. Okay, in the place of x, I'm putting 8. So 6 times 8 plus 7 should equal 55, right? What is 6 times 8? 48. What's 48 plus 7? It is, in fact, 55. So did I do this correctly? Yes. Okay. Are there questions on that one that we did? Okay. So let's take a look at this next one. Okay, take a moment to write that one down. All right, so here's my equal sign. What side of the equation am I going to start on? The right or the left? Where do you see the variable? The right or the left? The variable's over here. Here's the equal sign. The right? Okay, so let's look. I have division. I also have addition. I'm going to get rid of this addition first. Okay? So what is the inverse operation of addition?
Subtraction.
Okay, so I'm going to subtract that number from both sides. That's using the subtraction property of equality. Okay, so now, this makes 0, so this whole thing right here is like gone. There's nothing there because 0 means nothing, right? Okay, what's left on this side? M over 10. Okay, now what's 7 take away 8? -1. Okay, all right, so next, what do I do to get rid of this 10? Well, what operation is currently happening right here? Division. So what is the inverse of division?
Multiplication.
Okay, so we're going to multiply by whatever's in the denominator. So we're going to multiply by 10 on both sides. Okay. So remember, when you have 10 in the numerator and 10 in the denominator, when you have the same thing in the numerator, denominator, what does it make? 1, right? What's any number divided by itself? 1, okay. So what's 1 times m? No. M. What's 1 times 5?
5.
What's 1 times 10?
10.
What's 1 times 100?
100.
What's 1 times m? M. Okay. All right. So let's now look at the other side. What's 10 times negative 1?
10.
What kind of 10? Negative 10. Okay, now let's justify this step. What did I actually do in this step up here? I multiplied. So this is your multiplication property of equality. Okay, and then do I want to end up writing my answer like this?
No.
I'm going to switch it. And so what property is that I applied? Reflexive property of equality. Remember, it sounds like reflection, but it's not reflection. It's reflexive because it's the same thing on both sides of the equal sign, right? Okay. All right, let's do a check really quickly, okay? So for our check, 7 equals, what am I putting in the place of m? Negative 10 divided by positive 10 plus 8. Okay, when I'm simplifying this side, am I going to add or divide first?
Add.
Think of your order of operations.
Divide.
Okay, I'm going to divide first, so I get negative 1 there, plus 8, right? Okay, now I can do this addition, but am I really adding these numbers? I'm actually subtracting them because they're different kinds, right? So what do I get here? 7. Okay, does it check out? Yes. Okay. All right. I have one I want you guys to try. Okay. Can I flip my page? Do you guys need more time writing? Is this example 4? Okay. I want you guys to try this one. Okay. See if you can give that one a try with your new shoulder partner. Okay? You can't see it. Can you see it now?
Yes.
Okay. So, what was the first step that you guys did here? Add? Because what's the opposite of subtract? Addition, right? How did you justify this step here? What did you do? Addition, property of what? Equality, right? Okay. When we added, this made 0, right? Nothing's here anymore. So all that's left on this side is n divided by 2, right? Okay. What was 3 plus 8? Okay. Now, when I look at this side, I have division here. So what is the opposite of dividing? Multiplication. That should have been your next step. Okay? All right, so when I have 2 in the numerator and 2 in the denominator, what does that reduce to? N, right? 1 times n, which is just n. Okay? And what's 2 times 11? 22. Okay? Now, what was the justification for this step? We did multiplication. So it was the multiplication property of equality. Okay? Who solved this correctly? Raise your hand. Keep your hand up if you also wrote down the justification correctly. Okay, good. All right, let's check your work really quickly. Okay, so for our check, we're going to put in 22 in the place of n. Okay, what is 22 divided by 2? 11. What is 11 minus 8? Does 3 equal 3? Yeah. Okay, so it checks out. All right, are there questions on that one, on how we did that? Okay. All right. I want to do one more, and this one is kind of different looking, okay? So I want to take a look at this one. Okay, so take a look at this one. In the previous problems, we always started by undoing the addition or subtraction first, right? We undid the addition or subtraction, and then after that we undid the multiplication or division, right? And so, like in the previous problem, I had subtraction, so I added to both sides first, right? In the ones before this, right, if I had addition, like for example on this one, I undid that first, and then I undid the multiplication last, right? Okay, but look at this problem. If I want to start out by undoing the addition, and I go to write minus 3, what's in the way here? What's in the way of me writing minus 3? Is there something on the bottom here? Yeah, there's something in the denominator. That's in the way, right? I can't just write minus 3 right here because I have something there already. So when you have that situation happening, you have to remove the denominator first. Okay? Does that make sense? Okay, so I'm going to remove this denominator first. Now, remember, this fraction bar means division by 3, right? So what is the opposite of dividing by 3? Multiplication. So I'm going to go ahead and multiply this whole thing times 3. But I'm putting the 3 where? Where did I just put the 3? In the top or the bottom? Look at this 3 I just wrote down. Is it in the top or the bottom? Top. The top, right? Okay. The reason why it needs to be in the numerator is because if I put it in the bottom, it's not going to help cancel that out. It has to be in the numerator so these can undo each other, right? Okay, now I'm going to also multiply this side by 3. Okay, in the numerator as well. Okay, so because you have 3 and 3 here, remember, what happens when you have the same thing in the numerator and the denominator? What's 3 over 3? What does that end up reducing to? 1. What's 1 times anything? Itself. What's 1 times 5? What's 1 times 10? What's 1 times 20? What's 1 times a flying pig? What's 1 times r plus 3? R plus 3, right? So what's left on this side right now is just r plus 3. Because really, these make 1, and 1 times anything is itself. Does that make sense why I have that? Okay, now what's 3 times negative 5? Negative 15. Okay, now what can your next step be? Now can we subtract the 3? Yeah, there's nothing in the way in the denominator anymore, right? Now be careful when you subtract here. Is that going to give you 12? No, what's it going to give you? Negative 18. Okay. Now, do I like the order that's written? No, let's change it. Okay, let's go back through and justify my steps. So, what was the first step that I did? I multiplied. So, I'm going to write multiplication, property of equality. Okay, next step I did. Subtraction, property of equality. Last thing I did I switch the order? What's that called? Reflexive. property of equality. Okay? All right, I'm going to give you guys one to try. I want you guys to try this one. I want you to try working on it with your shoulder partner. Can we take a look at the solution? How many of you got negative 12? Raise your hand if you got negative 12. Okay, good. So, were your justifications multiplication first and then subtraction last? Okay? How many of you got the justification right? Okay, now remember, we're going to go ahead and check, right, and see if we did this correctly. So, we will plug in negative 12 plus 8 divided by 2 should give us negative 2. So, when I check this, do the top part first. What is negative 12 plus 8? Negative 4 divided by 2. Okay. Now, what's negative 4 divided by 2? Negative 2. Does it check out? Yes. So we can check and see if we did it correctly. Okay. All right. Are there any questions on what we did with this today?